All right, today's lesson is going to talk about the properties of matrices. In case you don't know, the plural of the word matrix is matrices. A matrix is a rectangular arrangement of numbers in rows and columns. This is kind of important. You'll see this giant thing of numbers here, collection of them, and they're separated by these giant brackets. Okay, so the idea here is that each of these, there are 3 rows, 1, 2, and 3. There are 4 columns, 1, 2, 3, and 4. Columns go up and down just like if they were holding up a Greek piece of architecture, and rows go across just like you'd want to have your rows, I guess, if you're rowing a boat, your oars. So if you're rowing a boat, this is how it is. It's across, sort of horizontally, where columns are vertically. That's how that works. Each of the pieces in here individually, each of these numbers is called an element. And when you draw them yourselves, make sure there's a little bit of space in between each one so you don't confuse this with a number 5,449, something like that. Don't get confused. Dimensions are really, really important. We're going to look at 2 reasons why today. And it's basically a combination of the number of rows and the number of columns. So for instance, there's 1, 2, 3 rows, so we would call this a 3 by, there are 1, 2, 3, 4 columns, a 3 by 4 matrix. And it's read 3 by 4 even though it's written 3 by 4. There it is. Interesting idea is you can use matrices when you're talking about equations of lines. Really quick way to solve a system of equations is using a matrix and using your graphing calculator or some other electronic device to row echelon form it, and you'll be set. The way we'll use it is you can perform you represent a figure in the coordinate plane using a matrix with 2 rows. The first row is going to represent the x coordinates, and the second row the corresponding y coordinate. So that's kind of what we're talking about. We'll do that right now, actually. Willie will build a matrix. Here's our matrix. Each of the rows is going to represent a different coordinate, an x or a y coordinate. And we'll try to represent triangle CDE as we go along. So the coordinates for C, we go over 1, 2, 3, 4, 5, and we go up 1, 2, 3, 4, so we put the 4 down there. So those are the coordinates of C. We'll do the same thing with D. D is over 7 and up 2, and E is over 5 down 2, so this becomes our matrix. How you could represent a polygon, such as a triangle, using a matrix. When we add and subtract matrices, we just need to make sure that they have the same dimensions, So for instance, this is a 1 by 2, and this is also a 1 by 2. Then what we're going to do is we're going to just say row 1, element 1 with row 1 element, row 1, column 1 element with row 1, column 1 element. We'll just add those together. So we will say that's going to be 7, and 3 plus 9 will just give us 12. Again, make sure to leave a gap in here so you don't think this is the number 712. I'll talk about the subtraction one as well. Some people will say there's no such thing as matrix subtraction, but really that you have to multiply each of these things by a -1 first and then add them together. I think that's kind of silly, but that's okay. The dimensions here are a 2 by 2 and a 2 by 2. Since they have the exact same dimensions, we can add these 2 square matrices or subtract them. So -1 minus 5 gives us -6. -9 minus 9 gives us -18. Let's go over here. 0 minus a -6 gives us a +6. And 2 minus a -7 gives us a total of 9. Again, our result, notice this, is the same size. So we have a 2 by 2 minus a 2 by 2 still gives us a 2 by 2. We add a 1 by 2 and a 1 by 2 and we get back a 1 by 2. Same thing would happen here. This is a 3 by 2. This is a 3 by 2. We would get back a 3 by 2. It says find the image matrix that represents the translation of the polygon. Oh boy, then graph the polygon and its image. Let's see if we can do this. We graph this. This is just -1 up 2, so here's where A is at. B is over 5, 2, 4, 5, and then up 2, so that's going to be B right there. C is over 3, then up 6, 2, 4, 6. Here's where C's at. It's a oh, look at that. It's a triangle. Oh boy, it looks something like that. Okay, we need to then move all these 5 to the right. So if these are all the x coordinates, To the right means I'm going to add 5 to them. 3 units down, since these are all the y coordinates, I'm actually going to subtract 3 from each of those. So here's going to be my new matrix. I'll take negative 1 plus 5. That'll give me positive 4. 5 minus 5 is 0. 3 plus 5, I'm sorry, that's 10. It's 5 plus 5. And then 3 plus 5 gives me 8. Let's see. 2 minus 3 is negative 1. 2 minus 3 is still negative 1. 6 minus 3 is 3. So here's my new matrix. It would be read out loud. 4, 10, 8, negative 1, negative 1, 3. There's usually a little bit of a pause in between each row so that people know, oh, he's stopping. Then what we need to do is we need to basically think about this being A prime, B prime, C prime. We need to graph this really quickly. Let me change colors for that. Boom, we'll start drawing in red, I guess, for a little while. We're over 4, we're down 1, that looks like this. This is now A prime. A prime. B is over 10, so 2, 4, 6, 8, 10, and down 1. So that's B prime. And C would be over 8, which would be right about here. And then up 3, 1, 2, 3. Here is C prime. We draw the little business going on here. There it is. And there's our new image. All right, here's our image matrix. And we usually don't necessarily write these things. We just want the matrix. It's okay if you do. You don't need to write the X or the Y over here because we understand that's what's going on. And there it is. It's based on context. The same thing would happen if you have a quadrilateral. Looks something like that. You can try it out if you feel like it. Next thing we're going to talk about, a little complicated. It's called multiplying matrices. I'm going to see if I can show you how to do this. And we'll have another lesson where we'll get a closer glimpse at this. I hope this will work. Okay, this is really confusing. The product of two matrices, A and B, is defined only when the number of columns of A, is equal to the number of rows of B. If A is an M by N matrix and B is an N by P matrix and the product is an A, okay, here's all you do. Determine the dimensions of this. This is a 1 by 2. This is a 2 by 1. Now, check the inside terms, the inside dimensions. 2 and 2 are the same. If those two are the same, you can multiply them. And guess what? When you multiply them, your resulting matrix is going to be the size 1 by 1. See how that works? Since the inside two are the same, you can multiply them, and your resulting product is going to be a 1 by 1 matrix. Okay? Over here, this is going to be a 1 by 3. This is a 3 by 1. Since the 3 and the 3 are the same, we can multiply them, and oh, our resulting matrix is going to be a 1 by 1. So there we go. Let me show you actually how we multiply. This is a little bit complicated, so let me just show you this. We'll actually take 4 and multiply it by negative 6. We're going to add to that negative 3 times 2. All right, so as I'm going across this way, I'm going down this way. So here's the first element with the first element, second element with the second element. Okay, then all I do is I just multiply these together. That gives me negative 24 minus 6. That gives me a total of negative 30. I put this in sort of matrix form here, and I put a box around it. That's my final answer. Okay, let's try this the same way. Again, as I go across this way, oh boy, as I go across this way, I go down this way. So I will have negative 3 times negative 5 plus 2 times 0. So that's the second one here with the second one here. And then I'll say plus 6, the third one here. I'll multiply by the third one here, negative 3. Okay, this gives me positive 15. This gives me 0. And this gives me negative 18. So I have a grand answer of negative 3. Boom, that's it. And again, this is a 1 by 1 matrix, and this is a 1 by 1 matrix. They're not always going to be 1 by 1 matrices. That'd be way too easy. So let's check out some more complicated ones. First off, let's make sure that we can multiply these. So this is a 2 by 3 matrix, and this is a 3 by 1 matrix. We definitely can because these two are the same, and we'll end up with a 2 by 1 matrix. This is a 2 by 2. This is a 2 by 2. We can definitely multiply them because there's a 2 in the middle, and our resulting will be a 2 by 2. Same thing happens here, 2 by 2, 2 by 2. We can multiply them because the 2's and the 2's are the same, and the 2 and the 2 are the same, so we got a square matrix. It's going to be awesome. Okay, Let's multiply these. As I go across, I'm going to use row 1. I'm going to multiply by column 1. So I'll be going down that way. So I have 2 times 0 plus 5 times -4 plus 5 times 2. That's pretty easy. To get the second row and the first column, I'll just take 1 times 0 plus 0 times -4 plus 3 times 2. Excuse me. After that, all we're going to do is we're going to add these together. So that's basically 0. That's a 0, and that's a 0. This will give me -20 plus 10. -20 plus 10 is -10. And 0 and 0 and 6 gives me 6. So my resulting matrix is a 2 by 1, so 2 rows, 1 column. Notice that the first row and the first column is what I have here. These are all added up. First row, first column gives me -10. The second row and the first column gives me my second row, first column element of my new matrix. Let's try it again. Again, as we go across with this one, we're going to go down with this one, and we'll just do row 1 and column 1. So that'll look like this. This will be -2 times -1 plus 3 times 7. Again, I went across with this guy and down with this guy. Let me see, maybe I can get like a little highlighter or something like this for the next one. Let's try this out. So we're going to talk about this guy times this guy. Let's see how this works out. Maybe this will make more sense. So we have -2 times 4 plus 3 times 5. That'll be that guy. Let me see if I can switch this up a little bit. Ooh, we could use green. We can now use this guy times this first column. Let's try this. So we'd have 5 times -1 plus -4 times 7. And lastly, we'll have this green one with this yellow one here. That looks like a kind of a weird mess. We'd have 5 times 4 minus 4 times 5. I'll close this matrix. Now I have all sorts of weird different colors here. Maybe I should move back to maybe something I haven't used. We'll simplify. This would be 2 plus 21. That's 23. I have -8 plus 15 is positive 7. Wow. I have -5 minus 28, so that's -33. And here I have 20 minus 20. That gives me 0. This is my matrix right here. Okay? Again, I had a 2 by 2 times a 2 by 2. My resulting matrix will be a 2 by 2. I'm going to leave this one for you. I hope you get some really, really good answers on it. If you want to check it really quickly after you've done it, it should be -17.3, -15. This is -20, and -6. It's totally okay that all of those are negative. Don't fret. It's totally okay. That's the solution to this guy. Hope this is helpful. Next time we're going to look at multiplying again, just trying it again, and then actually applying these, giving some sort of measure to what are these numbers, what could they possibly stand for, so we'll have some word problems. Good luck with that one.